Hi, my name is Evgeni Dyulgerov, and I'm going to present you about securing AI-powered systems, threat challenges, and best practices. Very fast about me. I'm an IT consultant with over 13 years of experience with a lot of different projects, web, mobile, blockchain. I've worked a little bit with robotics as well, CRM, ERP systems, and lately machine learning and cybersecurity. Also co-founder of Digitalix, an IT consulting agency focused on .NET and cloud projects. Lecturer at the Cybersecurity Department of Technical University of Sofia, Ph.D. candidate there, focused on application of AI in cybersecurity for the defense of critical infrastructure. Those are things like nuclear power plants and so on. And also with a team of authors, we are co-authoring a couple of books focused on cloud security, and here is my contacts. So, what is the presentation about? It's about AI in cybersecurity, security risks of AI-powered systems, adversarial AI, or how AI could be used for attacks, securing AI-enhanced applications, and future trends in AI. So let's start. Why should you care about AI at all? Here is some statistical information. There is a large growth of jobs that require AI skills, like AI architects, data science specialists, machine learning specialists, and more. And also a huge rise of jobs that requires cybersecurity skills. Also, AI-driven cyber attacks are on the rise. You know that deepfakes are increasing, also some other false information and so on. And AI could be used both as an attacker and a defender. So not only can AI be used to attack, but also to defend our enterprise environments. And also big tech companies are employing a lot of AI experienced professionals and PhDs. And for example, Cisco can send a lot of its consultants to Ukraine to defend its government against hybrid cyber attacks. So this kind of specialists are in high demand today. Also, AI-driven tools would be a standard by 2030. By AI-driven security tools, I mean tools, for example, that could perform some kind of automation. For example, automatically create incidents in ServiceNow or tasks in Jira. And of course, more complex tools that perhaps scan and analyze your environment, give you some recommendations on how to improve it, or maybe even do the improvements themselves. And other statistical information, AI reduces its response time by a lot due to this automation. And some researchers say that there is an improvement in the operations of business efficiency. That's based on research that say that AI improves developer performance by up to 35%, which means that we still cannot replace developers, but we could, in a team of several developers, we could perhaps lay off one or two of them. Just like with CRM and ERP systems, you could lay off sales professionals and so on. And a lot of organizations believe that AI enhances security, something that is not on this slide. Also, a lot of organizations believe that when using AI tools, they actually increase their security risks. So that's why this presentation is relevant. And a lot of AI governance laws have come into place, like AI Act, this AI framework, and others. So let's talk about AI in cybersecurity. How can we use it? We can use it for anomaly detection, API traffic, behavior analysis, and user authentication, automated threat detection response, rate limiting and API abuse detection, data protection, API encryption monitoring. Let's go through all of them quickly. So let's say we have some sources of information like application logs, network logs, and so on. We use that data to train our machine learning model, and we train it so that it can detect anomalies in the application logs, in the network logs. And once it detects an anomaly, it could create an alert, maybe log an incident in ServiceNow, generate some report for Power BI, or do all sorts of things that we want it to do. What is behavior abnormality? Let's say we have a senior software developer that does everything that a software developer should do. I mean, he joins Scrum meetings, perform code reviews, things like that. But what is abnormal behavior? That's when in 3 in the morning, he starts to download like 50 gigabytes of data from sales, marketing folders, and so on. That's usually abnormal behavior. And a lot of companies actually record Teams calls and other meetings in order to then analyze these meetings with artificial intelligence to understand how the employees feel, whether they are plotting something against the company or so, or things like that. And a lot of HR teams actually employ AI tools to analyze interview recordings in order to understand whether the candidate is a good fit, his personality type, and so on. So basically, AI tools are used throughout all the departments of a company, and they're becoming a norm. A little bit about threat detection and response, automated. So basically, again, we have an enterprise environment. Again, we scan it, analyze it, find vulnerabilities and threats. But not only that, we can also automatically respond to threats. Basically, let's say we have a container instance that has been damaged in some way. We could basically remove that container instance and raise a new one. Or perhaps we could box some APIs from which we receive some harmful network traffic, or do some other kind of action that actually improves the security of our environment. There are lots of options. And again, we could automatically log incidents in ServiceNow, generate reports, and so on. And of course, rate limiting and API abuse detection. Basically, we could limit the amount of requests to certain APIs based on certain policies and rules. And about data protection, that's a topic of itself, but what we should do is basically encrypt the data at rest and in transit, control the access to the data, and make sure that everybody accesses the data with the least privilege. Nobody should have administrative rights if he doesn't have to, and things like that. And maybe you know, but actually Snowden managed to steal so much data exactly because he had a lot of privileges that he shouldn't have. Also use secure data centers, cloud storage, rotate your keys periodically, secure data disposal, following policies like GDPR and so on, and secure monitoring and incident response and regular security audits and penetration testing. So a little bit about adversarial AI and model exploitation. How can we use AI for attacks? First of all, what is AI? That's not something that thinks. Those are machine learning algorithms. There are a lot of them here, grouped in different types, like for regression, classification, clustering. They could be combined to create interesting solutions. And I suggest to anybody who wants to deal with artificial intelligence, don't learn just the large language models. Go to data science, go to machine learning, and so on, so that you can actually get into the topic. So let's go to a so-called convolutional neural network. That's a machine learning algorithm that uses the operation convolution. I don't have the time to go into details, but basically that's a deep neural network with a lot of layers, and each layer extracts more and more specific features from the previous layers. So let's say the first layer extracts, let's say, the contours or the form of the image. Then each subsequent layer extracts a group of pixels, perform some operations on them, until at the end we could perform some kind of prediction on the end date. Basically, we could predict whether that's an image and whether that image is the number 7. So how can we use that in practice? Let's say we have a deep learning botnet-based detector that is a neural network that analyzes network traffic and tries to make a prediction whether it's harmful or not. The problem is that machine learning models could be easily fooled. For example, John McAfee back in the day managed to fool a Tesla car model by putting black tape on the speed limit sign of 35, and the car cameras figured that this is not a speed limit of 35, but a speed limit of 85, which usually anyone who has good eyesight, is not drinking anything, could easily recognize that it's not the number 8, but the machine learning algorithm didn't do that, and that could lead to a speed ticket and, in worst case scenarios, fatalities. So, a question for all of you: who is legally responsible for AI-induced fatalities? How many of you think that only business owners, owners of the software, are responsible? Please raise your hand. How many people think that company owners are responsible for AI? Nobody? Okay, that's good, because that's true. Everybody is responsible for AI. That's developers, testers, those who train the models and everything. And of course, the first party that is liable are the business owners, but everybody along the chain is also responsible. And here is a gun-based attack engine. Basically, we could use generative adversarial network, which is a combination of two neural networks. I'll try to explain it as simple as possible. Basically, the first network generates artificial examples, or in our case, artificial network traffic that tries to fool our botnet network, Defender. And we have a discriminator that tries to figure out whether that traffic is artificially generated. And those examples who actually get passed by the discriminator could be sent to the botnet detector network that we test, and we can try to see whether we could fool our defender or not. And that's a way to generate a lot of attacks very fast and eventually be able to fool a lot of different defenses that use AI. So how do we actually prevent that? Well, basically, we introduce the same gun algorithm into our defense. Basically, all the data that is wrongly labeled as safe traffic should be passed to the training data of the Defender model, of the deep learning-based botnet detector, and that network should be retrained along with all the newly acquired data. And then we update the weights of the victim model, and perhaps on the next iteration, our deep learning neural network would correctly qualify that we have attacker network traffic. And as many of you have probably guessed, that is not a one-time process. Basically, every time we have new data, we have zero-day exploits and so on, we have to retrain our models again and again. So that's a process which we have to do over and over in order to improve our AI defenses. So what are the security risks of AI-powered systems? Most of you probably have heard about OWASP top 10 for large language models. They are listed here along with where they apply. We can have prompt injection where users enter prompts that could expose sensitive information or some key information about the LLM models and so on. We can have supply chain vulnerabilities where some kind of updates to some third-party services are used to exploit our systems. The data and the models could be poisoned and so on, but there is something that is heavily underestimated, that's misinformation, because large language models could hallucinate. So we should never overtrust an application that uses AI. We should basically, there are design patterns that that we have a lot of different large language models. For example, the second and third large language model verifies everything that's generated by the first large language model. So we can have different design patterns where large language models check each other, but we should always monitor and log everything, have humans in the loop, and so on. And of course, there are other frameworks like Bit-Atlas framework that also lists a lot of attack vectors and mitigation strategies and so on. So securing AI-enhanced applications. What is a typical AI-enhanced application? Let's say we have some kind of front-end .NET application, mobile, whatever. I won't go into details how it's implemented, CQRS patterns or things like that, but it usually communicates with things like Azure Cognitive Services, our own custom machine learning models, third-party APIs, maybe some kind of automations, large language models, and so on. For example, let's say we have an insurance company business, and the user takes pictures of his damaged car, also takes pictures of some insurance documents, and writes some chat message to the software, basically maybe some angry message or maybe some fearful and sensitive message or whatever. So that application basically takes these pictures, analyzes them, analyzes what estimates the damage to the car, then analyze the text from the insurance documents. It can pass all that data. It can perform also semantic analysis on the text and analyze how the user is feeling. It can pass all that data to the large language model, which can perform things like retrieval, augmented generation to fetch some additional information. And then it can, in the unified resource aggregator, it could aggregate all that data and pass it back to the user. And it could be a lot more complex. We can have a lot of multiple large language model agents functioning in such an architecture. So how do we defend it? We can have secure design patterns. I won't go into the so-called AI agent design patterns. I'll go into some more basic things, but anyone who is a developer probably knows the classic API gateway pattern or the so-called facade pattern, where we have front end at the front, And we have an API gateway that serves as a facade through which all the requests are processed. There is a lot of logging, monitoring, authentication, load balancing, and things like that done at that level. And all the requests are then passed to the backend services. Well, we should have something similar when we have generative AI solutions. Basically, all the requests that are done to our AI services should again be rate limited. They should be stored, monitored, and logged because we could be under some kind of prompt injection attack or something else, and we should know that. And basically, everything should then be reported to the proper teams. And a little bit about zero trust architecture. That's a very simplified diagram. We should basically not only care about our applications, but the entire infrastructure. We should strongly authenticate all the users and third-party services that access our application. We should have device compliance for our endpoints. We should comply with the policies that are specific for the organization, like GDPR, NIST, and others. We should use threat protection and risk assessment using tools like Azure Defender for Cloud or Azure Sentinel that could be extended with custom machine learning solutions. We should also perform traffic filtering and segmentation. All the data should be classified, labeled, encrypted, the things that I showed at the start. And that's it about security very fast. So a little bit about future trends in AI cybersecurity. I've already talked about AI-powered threat detection and response. I've talked about AI-augmented cyber threats. Something I haven't talked about is quantum-resistant security. As some of you may know, quantum computing is becoming a norm. And a lot of cloud providers are starting to provide services that involve cloud computing, like Amazon. The European Union is basically developing more complex encryption algorithms that are quantum resistant, because with quantum computing, you can basically break the existing encryption algorithms quite fast. Also, there is the so-called cybersecurity as a service paradigm, where just like infrastructure as a service and some of the other as a service paradigms, so basically we could have a single solution that scans our environment, gives us recommendations, and maybe automatically do modifications to our environment to improve the security. And big tech companies are currently taking that paradigm to heart and are trying to develop such solutions. I mentioned Azure Sentinel before, so things like that. And of course, AI-powered compliance, where such tools are basically helping us automatically be compliant with policies like GDPR, NIST, and others by, again, scanning our environment and giving us recommendations how to be more compliant. So a question for you, how many of you have seen these movies? I'm certain that most of you have seen the right one, but how many of you have seen the left one? Let's see. Okay, great. Because the left one, I won't spoil it, it's about three pilots that get a fourth partner that is a powered fighter jet with a nuclear workload that tries to destroy humanity, but the three pilots stop it. Well, the thing is that the left movie is already real. We already have AI-powered fighter jets using deep learning neural network, and the only reason that scenario isn't happening is because the developers haven't let the fighter jets take autonomous decisions. All these decisions are taken by the pilot himself. So the question is, when would the second movie become real? And another question, would you trust an AI pilot? How many of you would trust an AI pilot? Well, I'm glad that not so many people, because you should never trust AI with anything that could lead to fatalities or loss of human life. And how many of you have seen these movies? Because, let's see, how many of you? Okay, a lot of people. Because in the next 5 to 10 years, these movies would also become real. You already have human-looking robots that are empowered by different machine learning algorithms. There are startups developing large language model-enabled robots and so on. And also, we already have some form of predictive policing. Let's say in China, they use social scoring and other data to predict how people behave. And for example, in South Korea, they use cameras to analyze the body language of people, to analyze their behavior, and could predict potential robberies with more than 40% accuracy. So predictive policing and large language model-enabled robots would soon become a norm. And some useful resources, some YouTube channels that I follow, like OWASP Foundation, Microsoft Security, Azure Academy, IBM Technology, Cisco, and others. 3 books that I highly recommend. Cybook or Cybersecurity Book of Knowledge. It's a very large book that is regularly updated, but it has a lot of things about cybersecurity. Everything new is added there. I recommend it to all my students. Another huge book, Machine Learning, Deep Learning, and AI for Cybersecurity, that has a lot of use cases for different machine learning algorithms in different cybersecurity cases. And a third book recommended by Bill Gates himself, How to Lie with Statistics. It's a book that explains how statistics could be manipulated and how we should defend against that. At the start of my presentation, I had some statistical information, but that all the data behind it is checked. So anytime you see statistical data, always check the data behind it. So thank you for your attention, and that's my contact information.
Thanks, Evgeni. We have a few minutes for questions. Any questions from the audience? All right, we have one.
Nikolai from WebPros. Maybe I missed it in the start of the talk, but do you have any examples of AI actually, except from adversarial gun networks and stuff, actually used in the wild for attacks, like as a component of attacking system?
Well, there could be one case scenario that is very harmful. Is using AI, you could basically create almost identical images of, how can I explain it? Let's say of cancer diagnosis or medical medical images of medical research performed on a patient. You can create almost identical images that could fool even doctors. So basically, you can introduce such images, and that would force people that are healthy to go have an operation, and of course, people that are in critical condition to look healthy. And that kind of attacks have already been performed on some kind of hospitals and things like that, yeah, that's a harmful example. So deepfakes, of course, you know about them, fake information, all sorts of things like that.
All right, other questions?
Thank you. Since you mentioned deepfakes and attacks using like AI-generated voice, AI-generated videos, images, can AI be used to detect such AI threats?
Well, yes, using the generative adversarial networks that I showed in one of the slides. But basically, we have to train our models with those types of attacks. Basically, we have to provide him with this type of data. We should label it as artificial and fake, and we should train our models in order to recognize that data. Otherwise, it would recognize that data as actually real, not fake. Basically, we have to train our model with a lot of fake data in order for it to learn to recognize fake data. No other way possible. There is no other way possible to defend against it. And of course, models would generate more sophisticated fake data, and we have to retrain our models, and that's a continuous process. Unfortunately, that's the only way.
All right, thanks.
What? Absolutely, there is a lot of money. Machine MLOps is basically focused on things like that specifically.
All right, thank you. Our time is up, so you can catch up with Evgeni outside in the speakers' corners. Thanks again, Evgeni.
Thank you.